All right. Whew. Welcome. Welcome to the stream. I'm Agent Uldra, and I'm here to just hack around, learn some things in functional programming, in Haskell in particular. For the past little while, I've been working on a little project to try and learn how to build a multi-user dungeon, a kind of real-time multiplayer game. It's text-based, has a text-based interface, but yeah, it's kind of like the MUDs, multi-user dungeons, were the precursors to modern-day MMORPGs. So I'm just hacking around, trying to figure things out, see how to structure this stuff, messing with libraries to embed Lua as a scripting language for our game engine, and doing things with concurrency and software transactional memory, and you know, trying to figure out stuff as we go and build things as we go. So yeah, not an expert, just a hacker, just a curious developer coding for fun and learning. So last week I was working on trying to get, oh, forgot to commit a file, looks like. Trying to get like the input-output system hooked up to the simulation, so that the simulation could send updates to connected clients. So I'll just stage that there. Simulation / event.hs, there we go. All right, so my idea here, my thinking is that there would be like an event stream that the simulation would be outputting as it's processing a tick, and that some kind of process that would be listening to the output of this stream, and delivering those events, that output, to the connected clients, so that when you're sitting in a room and you type a command like look or something like that, it responds with the output of the command. If something happens passively in the simulation, like another character avatar enters the same room as yours, you'll be able to see that update come to you. If mobs and things like that are moving around and doing their thing in the simulation, you'll be able to see those, all that good stuff. So just trying to figure out the structure for that and how to get that to go. So we're kind of looking at something like a channel with a dedicated listener on the channel. And so the simulation writes to the channel, and the listener just listens to that channel for things and delivers it to the, basically like kind of treating each connection like like having an inbox. Right. So did a little refactoring. Moving some code into this simulation state type here, which is going to have all the variables just for the simulation stuff, so just for the game engine like things. And out channel is that channel I was just mentioning right there, out chan. All right, so a channel of simulation events that can be written to. And I think right now all we have is like an out channel there. We run the simulation and the tick function here. This is what runs sometimes, some number of times per second. It's going to eventually be running the engine, like the game code to actually run the game that we're developing. But for now, just to get things testing, we're just writing out to that channel the same event every tick. Right? Cool. Let me just make sure I got chat popped out here, and then we'll get to it. Pop out our activity feed. All right. Okay. So what does this look like when we run it? We can all run Bakamud. Okay, so it's just in a loop constantly. Simulation start. We try to read the teach-in. We get some event. Something happened. Testing outbox pattern. Right, over and over and over again. Okay, so kind of going. Next, we need to, I guess, figure out how to deliver these events to a channel. How to write them to the output queue of the connection, sorry. That's what I'm going to try and figure out next, I guess. By the way, if this is your first time tuning in, welcome to the stream. I'm totally cool. If you've never, if you're just Haskell curious, and you've never really touched this stuff before, feel free to ask questions. I'm totally fine with taking diversions and distractions. Hey, what's up, Twitch TD? Welcome to the stream. Long time no see. Definitely. Yeah, we're still running one. I mean, it's not a tiny project. I probably chose a bit of a big project for this one. Yeah, we're still working on it. I've made a fair bit of progress, you know. I experimented with the Lua library, so we have a Lua interpreter that can run Lua code. We're able to get Haskell functions pushed onto the Lua stack so that our Lua code can call Haskell. And of course, Haskell can also call Lua functions. So we have the bidirectionality there. And also added a Lua parser so that we can parse declarations written in Lua source code and interpret them into Haskell data structures for the purposes of creating things like maps and other sort of objects we need to declare. Yeah, so a lot of interesting stuff there. Now I'm just like connecting up, trying to find ways to connect up the disparate parts. Right, we've got a simulation, we've got the low-level networking of the server, connections, and I'm just trying to like connect things together so we can start sort of seeing the black box, the black triangle moment come together. Right, where we can see output coming from the simulation to the connection, and we start processing other commands other than like the basic server commands. Yeah, so all right, so events. The event type right now, we have something happen, text client connected, and it's going to be hard, I think, to enumerate all of the domain, all the events that could happen in the simulation, because some of them we're not going to be privy to on the Haskell side of things, right? If we imagine that the game logic itself is going to be written in Lua for the most part, right? We have to handle things fairly generically on this side, on the Haskell side. So what I'm getting at is I have no idea what to do here. It's just kind of a fuzzy feeling that this is a direction to go in. And so I guess if I was to describe it, right, we have the idea of the game designer is one user who's writing code, who's trying to develop a game to run on this server. And we have the user who's connected to the server who is waiting for these game updates to come in, things that have happened. And they're really looking for, I guess from the perspective of the server, or from the perspective of the user, they're looking for interesting things that have happened during the game, during the simulation. But what do we call that thing? Like, I've got something happened here. It's like just a generic whatever, but there's going to be some events that are particular to the user who is playing the game. They're going to be like things that happen in the same room as them, basically. In the same room as their avatar, I guess, is the one thing. And then the other thing could be more like system level things, right? Which is like maybe client connected, like somebody connected while you were in there, or it could be some other kind of like server admin event, that kind of thing. And I guess there's different kinds of events too. There's like the output of a command. Right, so if I type in while I'm playing the game, look. Right. Right now, the way I'm thinking this is going to work is that look is going to go in, and it's going to get processed by the game designer's code. Right, as a command, they're going to parse it, and we're going to give them some kind of structure of like, here's the little tokenized here's the list of tokens basically to your function, and you deal with it and parse it. And then it's going to be up to the game command logic to handle that and respond to it. Right? Mm-hmm. And what I want to be able to do right now, I want to be able to get to the point where we can maybe type that look command or do something, you know? Let me boot up a client, start the server. Bakamud. Prepare. So connect to it, we get our message of the day. Right, and that's the MOTD command I sent. That's like a specific command that's implemented by the server. Same with login and register and things like that. But now if I type like look, I want to be able to get an output from the server that says like you're in the room. Or when I like log in and connect, and connect to my character, I should also kind of see something, you know, see the room I'm in, start playing the game. That sort of thing. So, and then the main, the other thing too is the entity system that we're going to be implementing too. Those are going to trigger a bunch of things. Let's just do a command. Like something happened to text. Let's just pretend something happened to text. I don't have a good name for it yet. Is a thing. And let's try and pass off the command to the Lua code. Like look. And write the Lua code that would like respond to the look command. And see what we need. Maybe that's a way to figure this out. Okay, so in order to the command stuff is in command. So we have unprocessed. So these are like the server commands. These are kind of like the hard-coded ones that we implemented. We saw, right? Login, message of the day, register, that sort of thing. The handle parse error one is for like handling parse errors on these. Unprocessed. Well, we parse those. And what we should get with unprocessed really is a list of tokens that we're going to pass off to the Lua code, right? The game code for handling the game input logic. So this input string is like a whole text string. It's all printable characters. Right, we're ending up with like one piece of text. So I think what we should do here is change this to token stream, token list, text. Something like this. Pass to game design, game logic, or parsing. Okay, we'll get GHCID running. And if we try to do token list here, we should get a type error. Yeah. Okay, so we should then get text data.text as text, and I think we have a split function for that. Let me Google it. More like text, text, list of text is probably what I want. Split on. I think split on only does split it once into two pieces, doesn't it? Oh no, several. Okay. Sort of like tokenize. Okay. So then we should be able to... No. And split on takes the string to split on first in the input text. So we can split on space and then the input. Okay, that should work. Let's fix these errors here. Server. Get rid of that. And this. key. That's good. I want to also... This is where we parse the command here. Write the command to the queue. Dispatch the commands. Command dispatch. There's dispatch command. Up arrow. Okay, so we handle just that way, and then we just print connection ID command for... That should handle everything, like including our new thing. So if we run this... Actually, let me get our client. And then we run the server. Okay, my simulation stuff is finding the output I want. To see, I think it worked. Well, we're gonna get rid of that. That. Yeah, we're gonna get rid of that. That. Yeah, we'll get rid of that too. Not using that at the moment, so we'll just silence that. Okay, there we go. Okay, token list, there we go. Look here. Look there. Look everywhere. Okay, so there's our token list. That should get passed off somewhere for further parsing by the game code. Technically, only if you're authenticated. All right, I want to be able to like make sure that we're authenticated before we start processing any, like letting any user input go into the game designer's code. You know, seems like a thing. Shouldn't be able to DDoS the game and play things and do things until you've done that. Okay, so we have the token list. Create a little commit for that. I will stage that as Bakamud work server. Debug stuff. Okay, and then this one. And we're replacing unprocessed token list. the type of tokenized string pass into the user game dev code. Mud code. I'm going to call it mud code. For parsing. Okay, so we need a way to call the game developer's parser and give them this token string. So this is where I think the design of this is going to be, I was thinking about this a little tricky. Right now with the server state, we have the state of the Lua interpreter in a central variable, gated by a tvar. Okay, the Lua interpreter state here. All right, and the Lua interpreter state needs to be updated atomically. All right, we need to run some Lua code, and it can't be run, the interpreter state can't be modified by two threads at the same time. All right, kind of have a bit of a barrier there that needs to be respected. At least I'm pretty sure that's how that works. Because it's got its own garbage collector and everything else. And we wouldn't want to be able to run a script that changes the Lua stack, like the call stack or whatever, and in two different places. Lua. Documentation. The reference manual for the current version. It's the API interface, maybe in basic concepts. coroutines, I'm pretty sure it's supposed to be single-threaded. That's what I'm looking for. Yeah, so we'd have to... Yeah, that's right. A single threaded in that sense. That like we can only have like one like interpreter. We can't have basically multiple threads of working off the same Lua VM state. But we could have a separate Lua interpreter for different threads of things. So like we could have our own Lua interpreter for just for parsing these token strings. But what would it return to us? You know? Like, it would have to return... It couldn't return anything we would know about. Unless, like, we decide that you have to return a particular structure. And then we'd have to, like, interpret that structure on the Haskell side dynamically and, like this is cool or not. But, like, the output of, like, most parsers is going to be, like, some kind of structure that's going to be, like, unique to the game engine that we just... The server code isn't going to know about, really. See, I don't know if that's going to work exactly. At the same time, this thread of execution in dispatch command, right, would have to... We could set this up maybe so that there's like a global lock on this Lua interpreter state here. Like, because all the TVAR is going to do for us is lock it atomically in a transaction, but only within an STM context, a software transactional memory context. We can't really do I/O in a software transactional memory context. So we can't actually call, say, the Lua interpreter to run some code, and then like just use the STM transaction to like read the Lua state, for example, call some Lua code and like do some stuff, and then put the state back in the TVAR, and then close the transaction and be done. Right? Because the Lua interpreter could throw an exception and all these other sorts of things. So it's not exactly going to work. Yeah, so we'd need like some kind of interpreter lock. And then then maybe like with an interpreter lock, we might not even need a TVAR state or anything like that. I've never actually implemented a mutex in Haskell. Trivial.mutex. I don't know what the heck a fey is. It's a pretty simple API. Whatever the heck a Fae is, though. Maybe we could write one. What the heck is a Fae? It's all over the place here. Google, help me out here. What's a Fae? Okay. I don't know if that's the actual... A lot of Faes. Maybe that's like part of a JavaScript package. Does control.concurrent have one? Again, Google, let's go there. SBV, GL, SDL2. Control.concurrent. Oh, there we go. mvar. Or it's like a semaphore. Okay. Yeah. Might not want to use them. Maybe STM has something. Yeah, the only problem with synchronizing over variables like this is like raise conditions of deadlocks. As different threads wait for access to our interpreter. We could end up waiting and waiting indefinitely. And we'd have to just make it's not the best, maybe. Yeah, so global interpreter. Yeah, we might just have to implement something here. Right. Server, state, interpreter, lock. T-bar lock state. Basically a Boolean. And then we'd have to like be very careful about how we write this code here. Which I don't like doing so much in Haskell, but I like to make sure that things are kind of like set up so that you can't screw up too badly. Which I'm not sure how we can do that with this API and this structure at the moment. But maybe in implementing this, we'll figure it out as we go along. Because I basically don't want to expose the state unless I have the lock. Get Lua state, for example. What would that be? Like a server state? And you could do maybe state. That GHCID. We did need to use record wildcards, so we need to add that language extension. Thank you. Okay. So we could do here. We can peek at the T in the transaction atomically. This might have to be, get Lua state might have to be in monad.io context for us to do that. Right, because we're gonna lock state TR. Or lock state. We're gonna lift IO, read TVAR. No, lift IO atomically. Right, and we're gonna look at the lock state. We're going to be waiting for returning, and then we match on that. What do we do if locked? If it's unlocked, well, we have to return. We said maybe some things we return nothing. And if it's unlocked, then we would This is kind of a weird function. All right, if we're going to read it atomically, we're going to look at the lock state. If it is, we're trying, this is get Lua state, so if it is locked, then we can't get the state yet. Oh, so we should, this is misnamed. We should call it lock the state. Because if it's unlocked, then we're going to lock it and return the state. Which means this isn't M anymore, right? Because if we tried to do it that way, this way, right? We're just reading it. But we can't change the state of server state M here as a parameter. Can't mutate it, right? And M doesn't contain anything about the server state or anything like. It's just some monad that does I/O stuff. So this isn't the right layer. Let's see. Maybe this might be the right layer. That's Bakamud server. Lock Lua state. Lock Lua interpreter. Yeah, checks are for sure, 100%. Yeah, the security on this is not fully implemented yet. The authorization system is not fully implemented. It's very much in a in development state. So don't follow that there. But we will definitely do that, both like in flight and at rest, and follow all that good stuff. So you want to do that properly. Of course you do. Of course you do, right? Of course. Of course. Okay, so this is better. So we're gonna get our Lua lock state, our interpreter lock state, tvar, by asking for it. Server state, Lua interpreter lock. Okay, and then we can get the interpreter lock, lift IOing atomically. Now we have to do that in here, so let's not bind it. Let's try and keep everything inside the STM transaction. Here, if we can. Oh, but we can't, because we want to do arbitrary I/O. This is going to be no bueno. I have a feeling this is not going to be good. Not going to be the way to do it. Alright, because if we bind it here, that's going to be a problem. Alright, do you know what the problem would be? For example, if we add this code. Okay. All right, this transaction, right, is gonna wait on this variable, this tvar, and get it and read it, and then bind it here. Okay. And then presumably we're gonna do some other actions with the interpreter lock. Right, which we don't want to do. So we got to make sure that we don't do anything. Except, well, no, actually, maybe I'm wrong. Maybe I'm done. I mean, yeah, sometimes can be. Atomically, we can read the tvar, the interpreter lock here. Because we only have to change the state of another tvar, which we can do inside this transaction. Yeah. So we get the interpreter lock, check it. If it's locked. Nothing. If it's unlocked. We can lock it. Write tvar. The value locked. And then we return. And then we got to get read the tvar for the interpreter state and pass that out. The interpreter state. I'll probably get that up here actually. This week, Checksor, you learned that Lewis Carroll was the pen name of a reverend in Europe. Most of his books, other than Alice in Wonderland, were about mathematics, such as linear algebra and symbolic logic. So I knew Lewis Carroll was a bit of a recreational mathematician. I didn't know he was a reverend. I also know that he was just a little bit too interested in people that were far too young for his age. Purportedly. I don't know if that's true, but I've heard that. Yeah, not super sure about that one. Let's look it up. English author and poet. Oh, and reluctant Anglican deacon. Not necessarily a reverend, but somewhat similar. Health problems, social connections, politics, religion, philosophy, blah, blah, blah. Literature. Okay, so here's maybe where the rumor's coming from. He was widely assumed for many years to have derived his own Alice from Alice Little. The acrostic poem at the end of The Looking Glass spells out her name in full, and there are also many superficial references to her hidden in the text of both books. It was noted that Dodgson himself repeatedly denied in later life that his little heroine was based on any real child, and he frequently dedicated his work to girls of his acquaintance, adding their names in acrostic poems at the beginning of the text. So, like, had close relationships with children. Not sure. Probably, though. Maybe. Hard to say. But that's kind of where it comes from. Yeah. I do enjoy Through the Looking Glass and those works, but also recognize that he's a bit of a questionable figure. Yeah, reluctant. Reluctant deacon. I wonder how that happened. Lure interpreter state is the variable we want. Okay, so then we combine this with TVAR. Interpreter state TVAR. And we can return pure just Lua interpreter. And, this is a very poor luck sort of situation here. Okay. Because this is an independent action, right? Which means that some poor sap like me is going to have to come in later and make sure to unlock the Lua interpreter and return control to somebody else who wants to run the Lua interpreter. Right. So I'm presumably going to be doing something with the Lua state. All right. And if I mess this up myself as the programmer, it's going to be very bad. So what I could do, though, is maybe provide a slightly better API that like does the locking and unlocking for me, so that I don't have to do this throughout my code and like try to make sure that I do it properly. Yeah, because that would be not good. Maybe with like a callback API or something for handling the Lua interpreter. That can I can run an IO or something like that. Yeah, I'll leave myself an apology. I mean, that's sometimes, you know, those are mistakes are just lessons you haven't learned yet, right? Yeah, so this would be like unsafe to use unless you use it correctly, right? Which is like fine, like sometimes that's just how programming goes, but hopefully in Haskell we can do a little better. But what would the return value of unlocking be? I don't know, maybe unit, I don't know. Probably not. Maybe the lock state. Okay. So pass in there, and what do we got to do when we want to unlock? Well, we got to do similar things as up here. We got to get these. These are the things we care about. And then we got to get the interpreter locked, just as before. TVAR. We got to check it. I'm just going to plop that there. Just get rid of these bodies. Okay, so If we go to unlock it and it's locked, that's the happy path we want. So we want to change the state to unlocked. We want to set the Lua interpreter TVAR. And then we want to write TVAR interpreter lock TVAR to be unlocked. And we're done. So we can return pure unlocked. If it's unlocked, then we just return pure unlocked. No, locked. That doesn't make sense. Kind of weird. Why is it not scope? I must mistype that. Oh, so I'm looking at the wrong line. And this one. This one. Interpreter. That's what I did. And big V. Oh, there we go. This feels a little, returning this will feel a little weird. Kind of makes sense though, a little bit, because like if you're trying to unlock Lure Interpreter and it's already unlocked, then somebody else has the interpreter state and you can't write it back yet. You have to try again, so locked. Kind of makes sense, I guess. It just feels a little odd, but I think it kind of makes sense. I don't know. So yeah, using these together, we'd be able to implement the command handling now for that, but we'd have to like manually write out these lock and unlock things and make sure that we do it just right in the code too. Like, you can imagine different interleavings of these getting in the way and leading to bugs. I don't want to overthink it, but I feel like we can write something pretty simple here called with a Lua interpreter lock. And that could be could take a function. It's lua.state to munit. No, we want the Lua interpreter state back. That's just it, System Carl. So it'll lock and unlock and then just wrap those statements around our callback, basically. I'm just going to double check the Lua Labrador. When we run, could say we're on some kind of the interpreter state. I think we run it in IO. Yeah, it's gonna be like IO something. Set global, get table. No, it's no. They're gonna be like IO something. But does it mutate the state is what I want to know. I think it would. I think it would. I think the state is just a pointer, a wrapper around a pointer. Yeah. It's an opaque structure that points to a thread and indirectly through the thread to the whole state of the Lua interpreter. The library is fully reentrant. It has no global variables. All the information about a state is accessible through this structure. So through this pointer, it's accessing the interpreter state. Right, and so we're just passing around the reference. So whatever's behind that pointer is what's going to get mutated by Lua interpreter. So yeah, this callback could probably just return unit and just do what it ever needs to do with the Lua state. And then returns a Bakamud server. Although I can make it return some type A that we don't really know. If we return the A from the callback, then we'll just return whatever the callback returns. I'm running it in IO here. Let's see if I can write this out. Hopefully that type makes sense. The other thing that could happen is that we could try getting the state. Right, we get the little lock interpreter. Like maybe we get the interpreter lock. If we didn't get it, what do we do? And if we did, we have the state. And we do something with that. Basically, we have to call the callback, I suppose, with that Lua state argument to get the return value. Yeah, maybe like this. this. We pass in the eclipse state. A hole, does that make sense? GHC, maybe. Yeah, no return value. So, yeah, we still have the nothing case to deal with. So if we can't get the lock, we could retry a number of times, or we could just give up and make you determine what to do if we couldn't run your function. We could throw an error of some kind in Bakamud. Although it doesn't throw errors, it's just reader T over IO. Right. If we make it maybe A, in the nothing case, we can just return nothing. And otherwise, return just return value. I keep writing in Tepa, Interpeta, Interpeter. Okay, and then this doesn't quite match. That doesn't quite match. I thought IO, this IO would work there. Yeah, let's see. So it is a monad IO action and MA. Oh, right, but return value. Okay, lift IO is actually expecting an IOA action. Okay, so if we make it the callback pipe IO, then it can run. Okay, so we could use this function, potentially, now, to implement that command handler. If I didn't have, like, freezing cold hands and closed my editor. Yeah, if you don't know where I am right now, it is super cold, by the way. So cold today. Good gracious. I'm just freezing. I work out of my basement. It's not super well insulated, so when the temperatures drop like this, it gets pretty chilly in here. It just feels cold. That's right. It's just a state of mind. That's all it is. Okay. So this dispatch command thing now. We should be able to use with interpreter lock to get the Lua interpreter to call a user Lua code to parse the tokenized string. So in dispatch command, I'm going to call handle tokenize list. And we'll pass in connection ID like we do for some limits. Tokens. Run GHC ID again. Not tokenize list, it's token list. Okay, so we need such a function, handle token list. Bakamud server unit. Okay, let's bring data.text and type into scope. Good. Okay, so now we got our hole. Okay, so now that we have the handle token list, we need to call our new lock Lua interpreter to do this. So with Lua interpreter lock, we get this Lua state. Oh, right. Okay. We made it return a value. Because I wasn't sure how we wanted to handle retries. So I'm just going to ignore the result for now. How to put that restraint on there. Okay. So now we just have a hole for IO some type. IO of some type. So now we can call something from Lua. No, we want to call the user function. Right, I think we want to push our values on the stack and then call the user's parse function. How do push? Okay, we can push C strings onto the stack. Can I push just Haskell strings onto the stack? Push integer. Push boolean. Pcall is how we call the function. Oh, we're also gonna need Lua load, I guess, to load a Lua chunk without running it. Or no, we can just assume the function's on there and we'll just make sure it's called a certain thing. Is insert get top, get table. It's gotta be push. C string. That's gonna be annoying to use, but I mean, we can wrap it and make it work, I guess. It's going to create a copy of the string too. Ugh. It's not going to be the most efficient way of doing things, but maybe we don't tokenize the string. Maybe your code has to do all of the tokenization and parsing. Because if we tokenize a list of, like, I mean, it'd have to be a pretty long list of strings, but potentially, you know, somebody could come in and type in, like, something ridiculous. You know, the whole novel of Moby Dick or something, right? And pass it off to your parser, and you'd be like, oh god, why? You might want that, but we might not want to parse, tokenize all of that. Because marshalling each text to a C string, pushing it onto the stack, is going to create copies of each of those strings. That's a lot of data shuffling to do. Yeah. I haven't really thought about how we're going to do like large command support either. Because there could be a place where we want to like edit a really large piece of text as input as a user. But we also want to protect the server from like hostile input. So I don't know if we there's a way we could like have a protocol for longer. MUDs have a way of doing that, kind of like having a separate protocol for longer input. Sort of like Postgres and other databases have like the copy protocol. All right, so you have like your normal query string, but like those are size limited. And you can actually have query strings that are too long. Usually it's pretty generous. The buffer size is pretty generous for the query strings. But if you want to copy like a bigger chunk of data, you use the copy protocol. And then it has like properly buffered input for large chunks of data, like special cases. The path for those things. Yeah. Probably overthinking it a little bit too much. Probably underthinking it a little bit too much. Let's see if we can just... Yeah, let's just push our strings on. Let's see. If we want to refactor it out and want to back out of it, it's code. We can change it. Okay, so... in that case... we're going to want to traverse a list of tokens, pushing them on the stack. Traverse underscore, that was in there. Okay, I guess gotta import it directly from data.portable. It's not like exported by Prelude. Okay, and push token. Push token, we're going to need the Lua state. Okay, so assuming we'd implement push token. So we push all of them on the stack, then we need a p call, I believe. So to call a function, first the function to be called is pushed on the stack. Then the arguments to the function are pushed in direct order. The first argument is pushed first. Finally, you call Lua pcall, and argues the number of arguments that you pushed onto the stack. All arguments and the function value are popped from the stack when the function is called. The function results are pushed onto the stack when the function returns. The number of results is adjusted to end results unless end results is Lua multiret. In this case, all results from the function are pushed. Lua takes care that the returned values fit into the stack space. The function results are pushed onto the stack in direct order, so that after the call, the last result is on top of the stack. If there is any error, Lua pcall catches it, pushes a single value on the stack, the error message, and returns the error code. Lua pcall always removes the function and its arguments from the stack, which is fine. Okay, so if message H is 0, the error object returned in the stack is exactly the original error object. Otherwise, message H is the location of a message handler. This index cannot be a pseudo index, whatever that means. In case of runtime errors, this function will be called with the error object and its return value will be the object returned on the stack by Lua pcall. Okay. So could also invoke debug tracebacks. Key. Again, so my assumption here when I'm writing traverse push token is that I'm pushing these tokens one at a time on the stack, like with some kind of var args kind of protocol here. But can Lua functions take a variable number of arguments, or some kind of Lua list? Can I convert to a Lua list? A table, I guess. A Lua table. Yeah. Okay, yeah. A Lua table. So let's create a Lua table with these things. So convert our Haskell list into a Lua table, and then push that on the stack. Okay, so create table. Can create a table on the stack for us. We get an IO unit. Then I can set table to set the values of it, maybe? HS Lua set table. Okay, so we can use set table at the stack index. Okay, and push our values onto it, I suppose. We do know the size of it, so we can give those hints. State, we have that. And length of tokens. And rec. How many other elements the table will have? I don't know what the difference of that is. Okay, we just get units, so presumably it'll create it right on the stack. This is the first thing we're going to create on the stack, so I'm guessing the index will be 1. So then if we want a HS Lua set table, Lua state at stack index 1, we have something and something, right? Where does HS Lua set table come from? light there. They need to be seeds. Okay, good to know, good to know. Pew, pew, pew. Where's our value? Maybe we can't. What's set table? How do I create a table with you, Lua? Create table. Open table. How is set table? What does set table even do? T is the value at the given index, presumably the stack index. V is the value at the top of the stack. Okay. Okay. So we have to push our values onto the stack and then call set table. Okay. This is a lot more complicated than I thought it would be. I might want to create like a little helper library for myself because I'm going to be doing quite a bit of this. Like Marshall Haskell types and common Haskell structures onto the Lua stack and back. Okay, so presumably we need to push, was it the key first? Yeah, the key first, then the value. And then we can call set table. Nothing ever too simple for a helper library. Yeah. I don't want to create too much in direction, but at the same time, like, this is very low level. It could get... I'm already kind of getting a little bit annoyed by it. I'm learning a lot, but yeah, I feel like I kind of just want to write like create the table with the list of things and just marshal it to, you know, a Lua table. Okay, so this is gonna be really weird. This code's gonna be really weird, and I'm running out of time here for the stream tonight. So I think we're gonna have to hold off on implementing handle token list for now. But basically, what I think this is gonna turn out to look like is that we create the table, and then we're going to basically traverse this list of elements or tokens, and then push each key in element onto the stack, call set table, and that's going to be like that done again and again and again until the table is completed. And then the top of the stack should be our table, and then we can p-call the function. Yeah, when you can't compartmentalize your life, compartmentalize your code. Words of wisdom, System Carl. Thank you so much for sharing. It's true. It really is. So with that, I will leave a little hole here. And let's see what we can push up here. We need to push up the lock state stuff along with our implementation of the Lua interpreter stuff. The interpreter lock bit, I think we could probably just commit all this together. It's not super clean, but it's good enough. Lua interpreter lock handling and tokenless stub function not fully implemented. Okay, cool. Let's push it up. I think that's that. So if this is your first time tuning in, thanks for watching. I'm Agent Ultra, and it's been a pleasure. All the code you've seen for this project, Bakamud, is up on GitHub, at least for the next little while. Or maybe forever, I don't know. I've been meaning to, like, transfer my stuff over to, like, a self-hosted Git forge of some kind, but I'm a bit lazy and haven't done it yet. So it's up on GitHub. I'll swap it, send you the link, paste you the link, whatever. There you go. You can check it out there. It's open source, free to mess around with, follow along with. Just learning, trying to figure out how to structure this thing, how to build an app like this, use various Haskell libraries like STM as we've been doing, also the Lua interpreter and embedding Lua code into Haskell applications and so on and so forth. And just a little bit of recreational programming. If you like what you've seen, I do these streams once a week on Tuesday evenings at about 10 after 8 in the Eastern Standard Time Zone. So you can check back then, next week. We'll see you then. Or if you're following me here on Twitch, or if you like and subscribe on YouTube, you have your notifications set up, you'll get notified when I go live or when I post the VODs for the stream that I back up on YouTube. So you can find all the links to my stuff, of course, on my website, agentultra.com. Or you can follow me in the Fediverse on the types.pl server at Agent Ultra there as well. We have links to my YouTube, Twitch, and website and all that stuff too. And that's all I've got for you tonight, folks. So thanks for tuning in and watching. Hope you stay warm. I'm going to go toasty up myself. And I'll see you next week. May all your monads be free and may your types always check. And happy hacking out there. Take care, folks. Peace.